functions and like how to create functions in Python and just like general stuff related to making your own functions in Python. So first off, what is a function? A function is basically a block of code that is a part of a program, but not included in like the main execution part of the code. So think of it as just like a block of code that does something consistently. So as you can see in this example, you have like print hello, print bye, and stuff like that. Um, a function will help you like instead of having like repetitive code like print hello, print bye, and then have that repeat endlessly, you can wrap that all up into one function and then call that function multiple times to like do the same thing. So it's just a block of code that does the same thing consistently. And this way, it provides the code a little bit of abstraction that will um, help you save a lot of lines of code, and it simplifies repetitive code and also makes your code pretty readable. So we can quickly look at a simple example of this. So in this example, we have just array A, 1, 2, 3, 4, and an array of B, 5, 6, 7, 8. And then say I want to add 10 to both of these lists. So I basically want to add 10 to each element for both A and B. So I can first just have go through use a loop for both of them. So like for I in enumerate, I'll add 10 to like the element in A, and then I'll do the same thing for B, and I'll print them out. So this way, like as you can see, I have basically two blocks that just do the same thing, but they also use, but all they do is just like, or they do the same thing besides like taking in like a different list each time. So I'm doing the same thing for both of these, and I'm basically using a lot of lines just to do the same thing. Instead of having basically the two blocks of the same code, what I can do instead is something like define a function like that takes in a variable x, and then for I num in enumerate x, I can have x of I equals num plus 10. And then I can even add that print function here, something like this. And then I can basically call that function. So my function foo, A, and then foo, B, and then pass both A and B in there. And it returns the same thing. So as you can see, I've used like 1, 2, 3, 4 lines of code instead of basically 6 lines of code to do the same thing. So a function in general is just a block of code that will help you reduce the amount of lines you have and will make your code more readable. And then next step, you will talk about just the Nandium function and how a function works.
Okay, so when you're writing a function, there are a few things that you should understand and remember. So one of the most important things in a function is remembering to use the def keyword, and that denotes that that basically tells Python that yes, this is a function that I'm writing. And then right after the def keyword, you write your function name. So this can be anything you want. Like in this example, our function name is my function. And right after your function name, you should have 2 parentheses. And inside those parentheses, you may or may not include parameters. And you may have 0 parameters, 1, or as many as you want. But if you don't understand what parameters are yet, that's completely okay, because I'll probably explain that in the next slide. Then after your after your parentheses, you should always remember to have a colon. And on the next few lines where you want to write the body of your function, make sure that make sure for each of those lines in the body of your function, you have an indentation, because Python is pretty strict about that sort of thing. And right, so all of your statements in the body of your function will be executed when you call your function name. You can go to the next slide. Right, okay, so let me explain a little bit more about arguments and parameters. So a parameter is a variable that's used inside the function definition. And it's defined inside of the parentheses that I mentioned before. And if there are multiple parameters, then you separate those parameters by commas. So let's look at this example first, the example def my function. So we have this function here called my function, and inside the parentheses right after the you can see that there is a you can see that there is a parameter called food, and you can think of food like a variable. But basically, when you call your function my function, you need to give Python a value for food. So let me now go back to what an argument is. So arguments are information that are passed into a function. So okay, let's look at the second part of this example. When I'm calling my function, notice how I'm putting a value inside of those parentheses right after I say my function. I'm saying pizza, and then I'm saying like ice cream, and then I'm saying fries. So let's say I put pizza. I put pizza first, right? So when I say pizza, I'm basically telling Python that, okay, you have pizza right here. Now make food equal to pizza. Remember food that was in our function definitions statement? Um, so because food equals pizza, then whenever you see food, whenever Python will see food inside of your function, then it's going to replace food with pizza. So in the statement my function pizza, when you write that in Python, it's just going to print out I like pizza. And for ice cream, it's going to say I like ice cream and then I like fries for the next statement. Okay, so like I mentioned earlier, you can have multiple parameters, and that would mean that you can have that would mean that you would have multiple arguments. So if you do choose to have multiple parameters, then you need to separate them by a comma. So in the first line, you can see that def my function, and inside these parentheses, you can see that there's name, comma food. So that's telling Python that there are two different parameters that are going to be used inside your function, name and food. Then you can see that we have this body of code where name and food are being used. And outside of your function, when you're trying to call my function, then what you need to do is to tell Python what the values of name and food are. So let's look at these examples where I say my function and then Marissa, comma, pizza. So then Python would take name and assign the value of Marissa to name, and pizza, and assign the value of pizza to food. So in this first statement where I say my function Marissa, comma, pizza, I would say, what would happen is that Python would print out name, colon, and then print out Marissa. And on the next line, Python would say favorite food, and then print out pizza, sorry, yeah. And then for these other examples, the same thing would happen. So Emily would be passed into name, and then ice cream into food, and Natalie would be passed into name, and then fries into food. And Jessica will go over this example.
So this is just another example of like Python's parameters and how parameters work in Python. So in this example, we have our main body here and a function called add. So here, add basically takes in two parameters, a and b, and then it'll print out a plus b. And in the main body, we're passing in 10 and 11 for the first add. And then in the second part, we're passing in string 1 and string 2, and we can add it. So here you can see that like variables, Python's parameters are very flexible. So there is a way to specify like parameter types if you really want to pass in like only integers or only strings into your function, or you can like check for the type in your function itself. But if you don't specify the parameter type, the type can be anything as long as it can perform the operations in your function. So here, if we run this code, you can see like if I pass in 10 and 11 and into add, it'll print 21. But if I also pass in like hello and bye into add, it'll still do the add, but it'll do the add for the strings instead of like adding them like integers or something like that. And let me share this too. So overall, like Python's parameters are like flexible, just like variables. And just to note, like to reiterate again, you have to separate your parameters with a comma in your function definition. All right, next is something called optional arguments or optional parameters. So this is pretty Python specific. In Python, you can also define something that's called an optional argument, which is basically just like with like your regular function header like this, you can have like def function name and then have a required argument. And then if you want an optional argument, you name the parameter, then you assign it a default value afterwards, and then do stuff in your function body. So if you have an optional argument, what you can do is you can call it with only the required parameters, like pass in only the required arguments, or you can pass in both a required argument and an optional argument. The general gist is just that the optional argument always has a default value. So Python will always it'll know that if you don't assign a value to the optional argument, it can revert back to the default value. But if you want to specify like the optional argument, you can just pass it in whenever you call the argument itself. And then an example would be something like if I have def, we can say add again, a b, and this is just like in our example. So def a b print a plus b, and then in our main body, we have a equals 10, b equals 11, and then add a b. So if I have the original example like this, basically a and b right now are your required parameters. So I can't just say like I just want to add a, because then Python will be like, well, what is b now? And then this won't work. So this will throw argument, and Python will say like its add is missing one required positional argument, which is just a really complicated way of telling us like, hey, you're missing this second argument for this function. However, if I make b an optional parameter by giving it a default value, say like b equals how about not 10, because that would be confusing. B equals 3. Then I can call add a comma b like this, and change the and like pass in argument to the optional parameter, or I can just call add a like this. But when Python goes back up here and checks the or it starts assigning values to the parameters, then it can say like, oh, so I do have the I did pass in like the required argument, which is a, but when it sees like I didn't pass in b, it will know that it can fall back to b equals 3. So next we're going to be talking about return values. Sometimes in Python, you don't want your function to just like do something and then be done. Like you want it to return something, to give you like you want it to give a value back to like whatever main function you're doing. And you can basically pass back values by specifying it or passing something back using the return keyword. So in this example, we have like a function called calculate average, and it takes in like a list of numbers. And then it'll calculate your mathematical average. And sometimes you don't want it to just like do something. You want it to like, just like in this example, it's returning back like the numerical average because you might want to use that for later or something like that. So then once it returns back like the average, you can capture it in like a variable, say like average num, and then print it out in your main function. So basically the general gist is if you want your function to return something, just write return and afterwards write like whatever data you want to send back. But just like a clarification is like once you like return a value in your function, that function ends there. So for example, if I return average here, if I write any code in the function after this return call, it won't be called ever because the function exits upon return. So we can check out like a quick example of this. So in this code, we have the last example is add a comma b, but instead of just having it print out the sum, you can return it like this. Another example is just like finding like the even number in like your parameter a, and then you can just find it like this. A quick question quick question, what is a? What type what data types can find even taken? Based off this for loop. You can drop the answers in chat. So based off the for loop, it's in general any data type that you can enumerate through in a for loop. So this can be like, and any data type where each element in this collection can be used with a modulus operation. So this could be something like a list of numbers or something like that, most commonly. And over here, as you can see, you can also return multiple values. And this will return it as a tuple. So if I run this example, in the main body, I'm basically like passing in a list of 1, 3, 5, 10, 13. And I can capture the results of find even in this variable called results. And then I'm printing out the the elements within this result tuple. So I can do it this way, where I just capture it, the return values as one big tuple, and then print out like each part by indexing into the tuple. Or I can capture each individual element by listing a bunch of different variables. So, and just separating them by commas. So what this does is basically in find even, I'm returning the index and the even number that of the first even number in the list. And in this part, Python will basically map like the return value to the variable that like matches it in the like that matches the position basically of the return values. So in this case, like I would be mapped to pause, and then num would be mapped to num, and then I can print out the values like this. So like what happens then if I run like b equals 1359? So like I pass in a list to find even that has no even numbers. What happens? So if we look back into find even, basically this will only return something if I find the even number. So what if I don't find the even number? What's the value of result then? Well, we can check it out right now by running it. And you can see that it's the none type. So none in Python is basically the type that denotes like no value. If you're familiar with other languages, it's basically Python's version of the no type, where it just like has no value. So just be careful when you're doing return values, because if Python sees that you're trying to capture some sort of value from your function, but there isn't like a final return value, then like you might run into some trouble in like more complicated pieces of code. So make sure that like it's good practice to basically have like consistent return values, or at the very least make sure you're checking for like none types if you ever have like a function like this where it might not always return a value at all. Sweet. So finally, we're going to be talking a little bit about variable scopes and scoping in general. This is a concept that is important to any coding language. So no matter like which language you're using, you always want to be familiar with scoping, because this will help you a lot in coding in general. So scoping is basically how and where a variable can be accessed, or like a variable or a function can be accessed within your code. This is basically like how you can how the language underneath the hood will map values to your variable name, and how you can access that value and what values you can access when you call a variable. So there are two types of scopes, local and global, and I'll get to the details about that a little later. Another thing you should be aware of is shadowing. And shadowing is basically when a local variable has the same name as a global variable. And the two names it won't conflict. So it's not something that's very bad and will throw an error or something, but this is something that might cause confusion as you're reading the code. So if I have a global variable called A, and I have a local variable a. It might be a little confusing to read the code after a few months of not like of developing that program, basically. So just be very careful. Shadowing is not something that is like technically bad or something that will like cause your program to crash, but it's something that you want to avoid because it might cause your code to be a little unreadable. So first, let's talk about global scope. Global scope is basically a global variable is basically something that can be accessed anywhere in the program. So it's a value that, so basically Python will map the value to your variable, and then you can basically access that anywhere, like in a function, in a class, or like in your main function. This is created outside of a function. So like you're not defining this in any function, or like you can define it in the main function, which is, and stuff like that. In Python specifically, you can access a global variable in a local function by using the global keyword. So basically, if you want to access a global variable in your function, you have to tell Python that you're trying to access a global variable first. And second is local scope. So a local variable is basically something that can only be accessed within a function that it's defined in. So it's basically all the variables, or not all of the variables, but like it's something, say like if I have x equals 10 in my code, this would be a local variable because it's only defined within my add function, basically. So we can check out an example of this. So for example, I have two functions. The first one is foo, where I call a global variable z, and then I create a local variable x, and then I add 100 to z. Next is like, for now, like we won't worry about whack because this one's pretty like tricky. But let's look at foo first. So if I run this, like, so let's like first in the main function, we have like z equals 100, x equals 10. And then I want to print out z and x after I call foo. So if you, like before we said that like here we're calling the global variable z, and then we're adding 100 to z. So this will basically, this line, first of all, basically tells Python like, hey, I'm calling like I'm referring to the global variable z. And then Python would be like, okay, I'm going to map like 100 to this variable then. And then next, Python will see that like we're creating a local variable x, and they'll map up the value 100 to x. And then finally, Python will just add 100 to z. However, once Python exits this function, this local variable value will basically just be destroyed because it's only local. So that this value 100 won't stay basically in like x. And then Python in the main function will still refer back to this x if it wants the value in this print. So that's basically why when we print z over here, it prints 200, because we've altered the global variable in this function. But for x over here, this one's global, but the x in our foo function was local. So this value basically isn't kept anywhere. And when Python prints over here, it will just print the 10 that was in the global variable x. So this also applies to functions. Functions also have like the everything I've said about like local and global variables also applies to functions. So for example, we have this function whack that has like a function within a function called inside func that takes in like a parameter x and then multiplies x by 10. And then in the function whack, we define a local variable called num equals 20, and then we'll call inside func on num, which will basically just multiply num by 10 and then return 200. So basically, when we look at this inside func, this is a function that is local to whack. So it can't be referred, um, it can't be called anywhere outside of the function whack. However, like technically, whack is a global function. So it can be called anywhere like in the main function or like outside, basically. So if we print out whack, it'll print out 200. However, like if I can't like call inside func outside of whack. So if I try like call inside func 10 here, it'll throw me an error saying like inside func isn't defined in this scope. Any questions about scoping? Sweet. All right. And next we have our 5 under 5. So question 1, what's the output of this code? So we have a function called foo, and we do x plus equals 10. So we're just adding x by 100. Then outside, we're defining x equals 9, and then we call foo over here. If I run this program, what do you think will happen? Right, so the answer would be an error. Basically, in this part, in the foo function itself, x isn't defined. So what Python will read is like x equals 9 in the global scope, but then once it enters the function foo, first off, it'll notice that like this x in foo is a local variable because we didn't use any global keywords before to like specify what x is. So this x is local. And second off, this local variable x hasn't had any value assigned to it. It's basically undefined in this case. So, and then it would be like, oh, I can't add 100 to like an undefined variable. So it'll throw this error, local variable x was referenced before assignment. That's basically just a fancy way of saying like, you didn't assign x anything like any sort of value before you started like doing operations on it, basically. So in general, make sure like when you want to access a global variable, make sure you specify that is global before like you try to change it. And if you want to like make a local variable, or if you want to make any variable in general, make sure you assign it a value before like you start doing things to it. So in order to fix this, there are two possible solutions. First off, you can define foo. You can define the global variable x by specifying like global keyword in foo, and then adding 100 to the global variable. And then it'll like add 100 to this x equals 9 and then print 109. What you can also do is have foo take in a parameter x instead, and then return the x plus 100. So this way you define a global variable x equals 9, and then you can say like x equals foo x, and then it'll also print 109. So there are many ways, like, and these aren't just the only two solutions. There are many ways to fix this. Just make sure like you, as long as like x has a value before you change it, and then like if you want to like return it as like, if you want to return, or if you want the function to return something, then like specify that with the return keyword. So question 2, what's the output of this code then? So I have like, again, function foo, but this time I'm having like a global variable z and saying z equals 24. And then I'm calling foo and printing z. So in this case, like, what do you think the output would be? All right, so in this situation, the answer would be 24. So like, this might be a little confusing because we didn't define like an actual global variable z outside over here. But you can actually create new global variables by using the global keyword. So basically what Python does is like, it'll see that once it gets to like this line global z, it'll see like, hey, I don't have a any global variables called z in my global scope. So what I'll do instead is I'll create it in this function and then assign it to 24 and then add that to the global scope. So, and then out here, once I hit that print function, Python will see like, oh, in my global scope, I have this variable z and its value is 24. And then I will be able to print it out as 24 over here. So if you try to refer to a global variable that doesn't exist in like a function or like in any local scope, you can Python will basically just create that variable and then assign it to like whatever value you have over here. This is both like good and bad. So like the good part is you don't exactly have to like define every single global variable you're going to use in like the main function or anything. So like you don't have to preemptively define z if you're not going to like use it, or if you're if in your main function. So like you can just start creating global variables like wherever you want to like define it. However, the bad part is like, say I do have like, or say I have a variable like ABC that's in my global scope. But then like somewhere like 1,000 lines later, I'm like I'm defining a function or something, and I make a typo. Like I say, instead of like global ABC, I accidentally say like global AB instead. Oh, Python will just like, oh, I don't see like this global variable called AB, so I'm just going to create one myself. And then that might cause like a lot of errors that might be hard to debug because it's actually not throwing an error. It's just like Python is just like being like a little too flexible and a little bit too forgiving. So if you want to like start creating global variables within like functions and stuff, just make sure like you use that carefully. All right, next is this a, first off, like, is this a valid function? And second off, what data types can parameter x be? So I have a function called wacky function that takes in a parameter x. And I say like, if x, then like return 100, else return 10, 20, 30. So first off, like, is wacky function, like, if I define this, is wacky function a valid function? Like, is my function body valid? And like, or will Python throw an error when I try to call it? Second off, what data types can parameter x be? Can I pass just anything into it, or like, can I only pass certain types of can x only be like specific data types? So this might take a little longer to think about, but feel free to drop answers or like any thoughts or questions in the chat about this.
Done.
Sorry, can you repeat that, please?
Is the class done?
Not yet. We've got 2 more questions.
Okay.
All right, so let's look at the answer then. First off, is this a valid function? Yes, because a function's return values can be flexible. For Python, you can return as many types and as many numbers of values in your function. So you don't always you can return one value in one condition or 3 values in another condition. That the number and type of return values doesn't have to be fixed, basically. Second off, X can be any data type that can be passed in as a Boolean expression. So as you can see on this side, wacky function can be an empty string, or it can be a number, or it can be a list, or just a Boolean. So as long as X can be evaluated by this if statement, it can be passed in to wacky function. And because Python is very flexible in what can be evaluated by an if statement, I'm honestly not sure if there is a data type that can't be evaluated by if statement, to be honest. But virtually, X can be any data type. All right, question 4. Can a function be passed in as a parameter to another function? So can I have a function that just takes in other functions as parameters and then do stuff with that? What do you guys think? I'll just give you this answer because this one is a pretty complicated answer, to be honest. But the answer is yes. So in Python and in many other languages, to be honest, functions are treated as their own objects. So I can have an example where say I have a definition food that prints x plus 100, and then function das that prints out x times 100. Then I can also have a function lamb that takes in a function f, and then just calls f and passes in 3 to it. And then when I can pass in just the name of the function, so foo or bass, and then it'll print out whatever. It'll basically pass in this function into f, and then pass in 3 into whatever function I've passed into lamb. So a function that takes in other functions as parameters are called higher order functions. So many languages now support this higher order function. So I can have now I can have things like lists of functions, and then pass in the same parameter to my list of functions. I can even store functions as variables and then pass them into other functions, or assign them to different objects and stuff like that. So this makes Python really powerful. I can even do something say I want a super customized sorting function, and then I can basically order an entire list by passing in a custom sorting function into another function that will order my list based off of whatever sorting function I passed into it. So be aware that functions are basically their own objects, and this can take your program to your programming to a whole new level, basically. And finally, what's the output of this code? So I have a function called say, and it takes in a parameter message and then another parameter times, which has a default value of 1. And then I print the message this number of times, basically. And then I have, in the main function, I pass in hello world and 3 into function say. So what do you think is, all right, so the answer is, it will print out hello world 3 times. So because we specify the default value 2 times, it's basically an optional parameter. So if I just printed like say hello world and I didn't pass in 3, it'll print out hello world times 1, which is just hello world 1 time. However, like this time I decided to specify the number of times I want to say hello world. So it printed out hello world 3 times.